Welcome to the training video, Device Usage. If you have any questions after the video ends, please message your onboarding partner. The prerequisites for this video are to have watched the normalization training video and completed the homework from it. Topics for this video are usage types, DC debug, logging methods, other resources, and a demonstration. Collecting usage data from a device is nearly always done via syslog. This requires the device to send its log messages to the data collector. There are two exceptions to this, checkpoint leer and hit counters. These two types will be covered in more detail during the intermediate training. As devices must be configured to send their data to the data collector, you should always ensure that the device has been configured as per the steps in our guides. There is the URL to access our documentation from the user center. The CLI command, DC debug, is used to view the incoming log messages in real time. To filter this data, you can use the grep command. Here is a sample of a DC debug output for a single log event from 10.250.0.200 to 192.168.0.11 on port TCP80. The very first line shows DC debug information regarding syslog UDP server, and this is the raw message that came from the device into the data collector. We then start to do our processing, and the remainder of these messages are our processing, and you can see this by different names to each of these lines depending on how far through the process it is. Initially, the message is identified as coming from one of the devices. In this case, it was 1.89. The usage regex was matched to this message type, confirmed it was for a Cisco firewall policy, and we matched it to a rule. We then process the message further, look at the contents again, and start to identify the specific fields in the message. We can see here the source was 10.250.0.200, which is what we see up here. The same goes for the destination. It was also included in the raw message type. The service, TCP port 80, we can see here is TCP at this section and port 80 as the number here. There was no application or user data in this message type. It is a very simple message type. And the final log entry for this shows that the usage record was generated. This is where the information is recorded to then be sent into the Security Manager application. Logging methods. There are three different types of logging messages that you need to be aware of. The simplest is a one-to-one match between the IP address of the syslog message and the management IP address of a device configured in Security Manager. One-to-alternate is where the syslog source IP address is from a different interface than the management IP address of the device. So this is added as an alternate syslog source IP. The final and most complicated method is many-to-one, and a single syslog source IP address is used for multiple devices. This is where we define a central syslog server, and it's applied to each of the devices in our interface, and a specific syslog match name must be used. This starts a second matching process which uses that syslog match name to search in the syslog message. More details of this will be covered in the intermediate training. Other resources that you have available are these KB articles, which are kept up to date and can be provided to customers. We have one for Cisco and one for Checkpoint LEA usage. The last KB article there relates to Cisco best practices for logging, as Cisco ASA have some very specific settings to get the best results. We'll now have a demonstration. I have a single device configured in Security Manager, and it's currently displaying healthy. The IP address is 10.50.0.190. This is my FMOS server, CLI, and we are going to watch the incoming syslog messages using the DC debug command. This will display data in real time. In debugging mode, there will be the incoming syslog messages, but there will also be other debug status messages from the data collector service itself. You can see an example there. I have another host here which I can use to generate traffic through my firewall. In this case, I'm telnetting from this device, which has IP address 10.250.0.200. If I generate this traffic, it is going to 192.168.0.11 on port 80. You can see I started that traffic, and we immediately had an update in the DC debug. Here is the source address of the message, which is the IP address of the firewall. We can then see the 106.100 message, the format, access list, policy, permit, the protocol, in this case TCP, the source IP address, source port, and then destination IP address and destination port. This is the same as what we saw in the PowerPoint slides. In this case, the device is ID 1/2. We then start to pass the 106.100 message, and we go through the same information. The object was named, the source object, destination object, the service, and then application and user are empty, because this is a very simple log format. In busy environments, you will need to grep for more information, to filter out the information you're specifically looking for. An example is I can do DC debug, up to grep 10.250.0.190, because I'm specifically looking for records from that device. If I then generate a traffic event again, you can see I now get just a single log entry. as it's processed by the syslog UDP server within the data collector. I do not see any of these other records because they do not contain the IP address that I'm specifically grepping on for. However, this is a good example to see exactly what is arriving from the device. The processing of it can be looked at in more detail in other ways, which will be covered in intermediate training, but this is one way, this is the way to filter for specific devices on a busy network. Thank you for watching this training video. Please message your onboarding partner if you have any questions.